in the last lecture we have learned about velocity and speed, and in this lecture we shall learn about the concept of acceleration. Now acceleration may be defined as the rate of change of velocity with time. To study acceleration, let us consider the motion of a car in a straight line. Now the motion of the car in a straight line, in the motion of the car in a straight line, the car may not always travel with the same velocity. Its velocity may change over time. For example, let us consider this velocity time graph of the motion of a car in a straight line. And as you can see from the graph, the velocity of the car changes with time. At 0 seconds, the velocity is 0. Then after a time 10 seconds, you see the velocity is equal to 24 meters per second. Then from 10 to 18, at that particular time interval, the velocity is constant, which means that the car is moving at a constant velocity. Then from 18 to 20 seconds, in the time interval 18 to 20 seconds, we can see that the velocity of the car decreases from 24 to 0. So in this graph, we see that the velocity is not always constant. It may remain constant for a certain time, that is from 10 to 18. Then from the other time interval, from 0 to 10 and from 18 to 20, the velocity changes. Now from 0 to 10 seconds, you can see that the velocity increases non-uniformly. Since it is a curve, so it increases non-uniformly. And from 18 to 20, the velocity of the car decreases uniformly, since it is a straight line. So the velocity of the car decreases uniformly. So acceleration is the rate of change of velocity with time. So in order to measure acceleration, we shall use or we shall define another quantity called the average acceleration. Now average acceleration over a time interval is defined as the change of velocity divided by the time interval. So for example, we take this motion of this car. The average acceleration from 0 to 10 seconds can be calculated by taking 0 to be the initial time, and again here 0 at t is equal to 0, the velocity is 0. Then at t is equal to 10 seconds, the velocity is 24 meters per second. So we have the initial velocity and the final velocity. The initial time being 0 seconds and the final time being 10 seconds. So in general, we can write the average acceleration as A. This is equal to V2 minus V1 divided by the time interval T2 minus T1. T1 is the initial time, and this V1 is the velocity at time T1, and V2 is the velocity at time T2. So here we have the change in velocity V2 minus V1 divided by the time interval T2 minus T1, and the change in velocity is denoted by delta V, and the time interval is denoted by delta T. So the average acceleration, usually denoted by A bar, is equal to delta V by delta T. So in this example, the motion of a car in a straight line, here from 0 to 10 seconds, in the time interval 0 to 10 seconds, we can calculate the average velocity. So from the time interval 0 to 10 seconds, what we have is at T1 is equal to 0 seconds. The velocity is also equal to 0 meter per second. Then at T2 is equal to 10 seconds, the velocity is equal to 24 meter per second. So the average acceleration, this will be equal to v2 minus v1 divided by t2 minus t1, and this is equal to 24 minus 0 divided by 10 minus 0, and this will be equal to, if you calculate this, you'll get 24 by 10, and that will be 2.4 meter per second square. So the SI unit of acceleration is meter per second square. So here the average acceleration in the time interval 0 to 10 seconds is equal to 2.4 meter per second square. Then we can also calculate the average velocity from 10 seconds to 18 seconds. So from 10 seconds to 18 seconds, as you all know that there's no change in velocity, so we expect this average acceleration to be equal to 0. So from 10 to 18 seconds, we have the initial time to be 10 seconds. So at 10 seconds, the velocity is how much? 24 meter per second. And at 18 seconds, the velocity is again same, 24 meter per second. So here we have a v1 and v2, the initial and the final velocity to be equal. So here your v2 is 24, v1 is also 24. Now t2 is 18 minus t1 is 10 seconds. So 24 minus 24, this would give you 0, and divided by 0 divided by anything is equal to 0. So we have the average acceleration from 10 seconds to 18 seconds. This is equal to 0 meter per second square. So here the acceleration is 0. Since there's no change in velocity, okay, the acceleration will be 0. Then we come to the next time interval, say from 18 to 20. Now in this case you can see from the graph the velocity is decreasing. So from 18 to 20 seconds, so from 18, so at t1 is equal to 18 seconds, your v1 is 24 meter per second, and at t2 is equal to 20 seconds, your v2 is actually 0 meter per second. Okay, then here putting the values, we'll get v2 to be equal to 0, v1 is equal to 24, t2 is equal to 20, t1 is equal to 18. So you'll get here minus 24 divided by 20 minus 18, you'll get 2. So here you'll get 24 by 2, you'll get 12. So here we have minus 12. So the average acceleration is equal to minus 12 meter per second square. Minus here indicates that the acceleration is a negative acceleration. In the earlier case, in the first case, you have a positive acceleration, which means that the velocity is increasing. And in this case, you have a negative acceleration because the velocity is decreasing. Okay, in other words, this is a deceleration. Okay, negative acceleration we also can also be called as deceleration or a retardation. Okay, when you actually decrease the velocity. So you can say from 0 to 10 seconds, okay, the driver of the car may press the accelerator, put on the accelerator and accelerate the car, which means he's increasing the velocity of the car. Then from 10 to 18 seconds, he's cruising with a constant speed. Then from 18 seconds to 20 seconds, he's actually applying brakes to the car to stop the car. That is to decrease the velocity of the car from 24 meter per second to 0 meter per second. Okay, so in the first interval, he's pressing the accelerator In the second interval, he's just moving at a constant velocity without any acceleration. And in the last interval, in this interval, he's actually pressing the brake and stopping the car. Okay, that is, the velocity decreases from 24 meter per second to 0 meter per second. So that is the concept of average acceleration. So as you can see from this example, acceleration can be positive, 0, or negative. Now we come to the concept of instantaneous acceleration. Now, just like instantaneous velocity, okay, it is the velocity at any instant of time. Instantaneous acceleration is also the acceleration at any instant of time. For example, in the motion of a car in a straight line, we have the velocity time graph. So we have velocity and time graph. In the first case, it is a curve, then move at a constant velocity. Then moves at a constant velocity. Then the velocity decreases with time. So at this instant, which is 10 seconds, the velocity is actually 24 meter per second. So I'll just write 24. So 24 meter per second, this is 10 seconds. Then at 0, the velocity is 0. Then in this interval from 0 to 10, you can see here that the velocity is increasing. Now the instantaneous acceleration will give you the acceleration at any instant of time. For example, here, if you want to know the acceleration here, then what you have to do is, you will have to draw a tangent at this point. And the slope of this tangent, okay, will give us the instantaneous acceleration. For example, if I want to know the acceleration at this instant of time, say at 11 seconds. Let's say this is 11 seconds. So I'll have to draw a tangent at this point. And here you can see that the tangent itself is in the same line as that of the velocity time graph. So here you can see that the slope is 0. And when the slope is 0, the acceleration is also 0. Here you can see that the slope is positive, which means that the velocity is increasing. And it is a positive acceleration. And here, suppose at this time, say 19 seconds. Say at this particular time, say 19 seconds. Then again you have to draw a tangent, and as you can see that the tangent is along this velocity time graph from this point, which is 18, and this point, which is 20. So we have this to be 18 and this to be 20, and here the acceleration at this point is actually equal to the average acceleration. As we have calculated earlier, the average acceleration is minus 12 meter per second square. So here also the instantaneous acceleration is minus 12 meter per second square. So here, when the motion is a uniformly accelerated motion, the average acceleration is equal to the instantaneous acceleration. Hence we have the slope to be equal to the tangent. The tangent is along this same line, and here you can see that the slope is negative, which means that it is a negative acceleration, or we call it deceleration or retardation. And this instantaneous acceleration, mathematically you can write instantaneous acceleration or express instantaneous acceleration as limit of the average acceleration, which is delta v by delta t, as delta t tends to 0. So it's the limit of this average velocity as the time interval tends to 0. And this is written as dt of v. So derivative of the velocity with respect to time. So that is the instantaneous acceleration. So this is similar to the instantaneous velocity. We have instantaneous velocity, just to recall, is equal to ddt of the displacement x. So the time derivative of the displacement x will give the instantaneous velocity. So here also the time derivative of the velocity will give you the instantaneous acceleration. Now we know that velocity is a vector quantity, which means that it have both magnitude and direction. So a change in velocity means that the magnitude, either the magnitude is changing or the direction is changing, or both the magnitude and direction is changing. So by acceleration therefore may result from a change in speed, which is the magnitude of velocity, or a change in direction, or a change in both the magnitude of velocity and the direction of the velocity. And just like velocity, you can have a positive, negative, or zero. Acceleration also can be a positive, negative, or zero. Now to explain that, we shall consider three position time graph of motion, okay, with positive acceleration, negative acceleration, and zero acceleration. So here is the first time graph, position time graph with a positive acceleration. So here we have a position time graph, and in this position time graph you can see that the curve is in the form of a parabola, and here the instantaneous velocity at this point is given by the slope of the tangent drawn at that point. The instantaneous velocity at this point is given by the slope of the tangent drawn at this point, and the instantaneous velocity at this point is given by the slope of the tangent drawn at this point. And as you can see here, the slope is negative, so here the velocity is negative. So here your velocity is negative, and here you can see that the slope is 0. So the velocity is 0, and here the slope is positive. So the velocity is positive. So the instantaneous velocity is positive, negative here, or 0 here, and negative at this point. So as you can see here, as time progresses in this direction, the velocity changes from where? From negative to 0 to positive. So you can see that the velocity is increasing from negative, which is a lower, to positive, which is a higher. So since the velocity is increasing, the acceleration will be positive. Okay, the velocity is increasing, so the acceleration is positive. So here we have a positive acceleration. Now the next case is for a negative acceleration. Now we have the position time graph to be in this manner. Then again here, the instantaneous velocity at this point is the slope of this tangent. The instantaneous velocity at this point is the slope of this tangent, and the instantaneous velocity at this point is the slope of this tangent. And you can see here that this one is positive, 0, negative. So here the velocity, instantaneous velocity, is positive. Here the velocity is 0, instantaneous velocity is 0, and here the instantaneous velocity is negative. So as you can see here that the velocity changes from positive to 0 and to negative. So here it means that the velocity is decreasing, alright, or it's changing its direction. So here, since the velocity is decreasing, the acceleration will be negative. Okay, so it's changing from positive to negative, so the acceleration is negative. And we have another case when the acceleration is 0. Now the position time graph says a straight line. which is inclined to the time axis. Then here the velocity at this point is a line drawn or tangent drawn through this line. Velocity at this point, again here also you can see that it's the same line. The slope of this line is equal to the slope of this line, and at this point also you can draw a tangent, and again here also the slope of this line is equal to the slope of this and is equal to the slope of this line here. So here you can see that the velocity is same at this point, and this point and this point the velocity is same, and since it is a constant velocity, the acceleration will be 0. So this is a case of 0 acceleration. Hence your acceleration can be positive, negative or 0. Now, although acceleration can vary with time, in this chapter we shall study only motion with a constant acceleration, or we call this motion with constant acceleration as a uniformly accelerated motion. And here we have a few velocity time graph of uniformly accelerated motion, okay, with some of simple cases. So in the first velocity time graph, we have the motion of a car, say, moving in the positive direction with a positive acceleration. And in the second graph, here the velocity is decreasing, so this is the motion of a car moving with negative acceleration. Then in the third case, in this case also, this is the motion of a car moving in the negative x direction. Since here the velocity is starting from initial velocity is minus v0 and the final velocity is minus v. So here the car is moving in the negative x direction. So the direction is opposite to that of the positive x direction. Hence the acceleration in this case is negative. And in the last case, here the velocity time graph, in this case the motion of a car, here we can see that the velocity is decreasing, so it is moving with a negative acceleration, and then at t0 the direction changes. So here the car is making a U-turn, so it's moving with constant speed, but at time t1 the motion of a car changes direction, so it's making a U-turn. So here this is again a motion with a negative acceleration. First we have a retardation, then again we have a negative acceleration due to the change in direction. So these are the four graphs of a uniformly accelerated motion. Now what can we get from these velocity time graph? Okay, suppose if car is moving with zero acceleration, that is if the car is moving with a constant velocity, and say that velocity is given as u. So the velocity time graph of the motion of a car with zero acceleration can be drawn by a straight parallel line, okay, which is parallel to this time axis, and the velocity of this car is u. So here the car is moving but with a constant velocity, so it's not accelerating. So here the acceleration is 0. Now from this graph I can get the displacement. So from this graph I can actually get the displacement from 0 to t. So what is the displacement of the car in this time interval from 0 to capital T? Now the displacement of this car is given by the area of this position velocity time graph. So this will actually give us the displacement of the car. If you calculate the area, this area of this rectangle, you will get the displacement of the car. So this displacement will be equal, hence this displacement denoted by S will be equal to the area, which is U into T. So from here to here it's U, and from here to here it's T. So you can see this length into breadth is equal to the area. So here we have the area U into T. So U into T will actually give you this area. Length, it's like taking length into breadth. So the area of this velocity time graph, okay, will give us the displacement. So here your displacement is U into T. So you'll have to remember this concept that the area under the velocity time graph will actually give you the displacement, okay, and that is equal to U into T. So this gives you the displacement. So we shall use this concept in deriving the equations of motion in the next class.